Electricity video 3. Now we're looking at the energy in that electrical circuit. So first of all, let's think about what we're going to learn. So we're going to think about what potential energy is and how we can create it by moving objects against an opposing force. We're going to understand therefore what electrical potential energy is. So we're separating unlike charges, positives and negatives, from each other, and therefore understand our electric circuit is the movement of the electrons that are negative towards positive, and therefore losing potential energy. So, you probably already know, hopefully already know, that the world is made of atoms, and atoms are charged particles. You've got electrons which are negatively charged, and protons which are positively charged, and neutrons which have no charge, so we're going to forget about them because we don't care about them for electricity. Most things have got exactly even numbers of positive and negative. Okay, so substances are uncharged, and therefore they're not behaving electrically. But if we can mess that up, what we notice is that a positive will attract a negative, and a positive would repel another positive, and a negative would repel another negative. Now, potential energy. Anytime we change energy from one form to another, we're never losing it. Okay? You cannot create or destroy energy. But we can change it from one form to another, and sometimes we don't notice the form we've changed it to. We store it as potential energy. So if we look at this example to the right, the weightlifter stops, she's holding up the weight. Okay? That is potential energy. It has the potential to turn back into kinetic energy and fall back to the ground. Okay? So we are never creating or destroying energy. We're just changing the form that it's in. Electrical potential energy is like gravitational potential energy. What we're doing is we're taking the charged particles, we're pulling them away from where they want to be. So the negative electrons want to be with the positive protons. They like them, they enjoy hanging out together. But if we pull them away, we've then got electrical potential energy. We need to use some energy to do that. So we're going to go, say, from chemical energy in a battery to electrical potential energy. And then they're going to move around, so it's going to go back into kinetic energy as it's given out. And along the way, some of that energy might go to a light bulb, so it might be converted into light energy. So as the electron gets pulled away, now we've got electrical potential energy there. And there we go back to our kinetic energy. One of the ways that we can do this is doing static electricity. So if you've ever rubbed a balloon against your hair, you have created static electricity. What you've really done is created electrical potential energy. And we'll look at a few examples in class of how we can do that. Now, an electrical force is dependent on two things. Dependent on the strength of those charges and how far away they are. Okay? The potential energy is equivalent to the amount of work you have to do to separate them. So the more work we have to do to separate them, the greater the potential energy we get. A couple of things to think about. When we stick a balloon to a wall, the wall isn't charged. So we can charge the balloon, but you're not charging the wall. So why are the balloon and the wall attracted? And if you do a big karate chop, what is it that stops that from passing through a table? We'll look at those questions in class.